Hello everyone, and welcome to Stuff I Found Interesting. Today's rabbit hole is space elevators. A space elevator is a theoretical structure that is intended to transport people and cargo from the surface of Earth to space without the need for rockets or other launch vehicles. The idea is to build a tall tower or cable that extends from the Earth's surface to a point beyond geostationary orbit, a distance of about 36,000 kilometers above Earth's surface. The basic idea of a space elevator is to use a long cable or ribbon anchored to Earth's surface, extending up into space, that can support a climber vehicle that can travel up and down the cable using a combination of propulsion and gravity. The cable would be anchored to the Earth's surface at the equator, allowing the climber vehicle to be lifted up into space without using rockets or other forms of propulsion. The concept of a space elevator is still largely theoretical, and there are many technical and engineering challenges that must be overcome before a space elevator becomes a reality. Some of the major challenges include developing materials that are strong enough to support the weight of the cable and the climber vehicle, designing a climber vehicle that is both safe and efficient, and developing systems to deal with the high radiation and other hazards that are present in space. A space elevator has the potential to significantly lower the costs of going to space by eliminating the need for expensive rockets and fuel. Traditional rocket-based launch systems require a huge amount of energy to lift payloads off the surface and into space. This requires large amounts of fuel, which adds significantly to the cost of space launches. A space elevator, on the other hand, would rely on a long cable anchored to the surface and extending far out into space. Cargo and people would be transported up and down the cable using vehicles called climbers, which would be powered by electricity generated by solar panels or other renewable sources. Because the cable would be able to lift payloads into space using only the force of gravity, it would require much less energy and fuel than traditional rockets. As a general rule, the cost of launching payloads into space is very expensive, with current estimates ranging from around $2,000 to $40,000 per kilogram, depending on the launch system and other factors. With a space elevator, a large portion of those costs would be negated. The ability to use a form of climber or elevator car to move things from Earth to space would be highly efficient compared to rocket engines that we use today. The trip would take longer, but a bit of extra time is a worthwhile trade-off when it comes to the amount of money space launches need. Sure, it's great and all that we would save money on sending stuff up to space, but how much could we send at a time using a space elevator? If it takes tons of trips to get anything worthwhile into space, then going the inefficient but quick way might be more beneficial. The cargo capacity of a space elevator would depend on several factors, including the design of the climber vehicle and the weight capacity of the cable. In theory, a space elevator could transport very large amounts of cargo into space, potentially hundreds of tons per trip. The capacity of a climber vehicle would depend on its design, including its size, weight, and propulsion system. The climber vehicle would need to be able to carry not only cargo, but also people and any necessary equipment. The design of the vehicle would also need to take into account the hazards of space travel, such as radiation exposure and extreme temperatures. The weight capacity of the cable would also be an important factor in determining the cargo capacity of a space elevator. The cable would need to be able to support the weight of the climber vehicle, the cargo it's carrying, and any other loads or stresses that are placed on it. The stronger and lighter the cable material, the greater the cargo capacity of the elevator. If and when we get a space elevator up and running, there will be a huge shift in how we handle space. The ability to get a large amount of equipment or structures into space in a cost-efficient way would allow us to have larger space stations that would be reliably refueled and resupplied. This would allow us to have longer-term missions and go further out into space than ever before. With an elevator, we could have a much easier time getting whole satellites into space. We could have multiple telescopes on par with the James Webb Space Telescope out there, allowing us to collect data at a higher rate and learn more about the universe. Those satellites do not all need to be focused outward. We could expedite projects like Starlink and provide easy and cheap internet access to everyone in the world. Additionally, with more structures in space that can house humans, we would be able to run more experiments than is currently possible on the International Space Station. We would be able to have multiple space stations that can each have their own area of focus. We could start bootstrapping our space industry and start mining and using resources from outside Earth. A functional space elevator would even open up new research opportunities in fields such as astronomy, materials science, and Earth observation. It would make it possible to launch larger and more sophisticated scientific equipment into space, allowing researchers to gather more data and conduct more complex experiments. The results of those experiments would be key factors in creating new technologies and advancing the standard of living for everyone around the world. A space elevator could make space tourism more accessible to a wider range of people. Traditional rocket launches are expensive and require significant resources, which limits the number of people who can afford to go to space. A space elevator would significantly reduce the cost of getting people people into space, making it possible for more people to experience space travel. Traditional rocket launches are limited by the availability of launch pads, rocket hardware, and fuel. A space elevator would not be limited by these factors, which would make it possible to launch more frequently. This increased launch frequency could make space tourism more appealing by offering more options and flexibility. A space elevator would make it easier to transport people and supplies to space colonies. It would eliminate the need for expensive and risky rocket launches, making it more affordable and practical to establish permanent colonies on the Moon, Mars, and other locations in the solar system. For things that would be too large for even a space elevator, we could move them up in pieces and assemble them in space. This method of construction would further reduce the cost of that equipment and would make colonization possible. A space elevator would use renewable energy sources to power its operation, making tourism more sustainable and environmentally friendly. This could make space tourism more appealing to people who are concerned about the environmental impact of space travel. Overall, a space elevator would revolutionize the future of space tourism and colonization by making space travel more accessible, affordable, and sustainable. It would open up new opportunities for people to explore and inhabit space, and could significantly accelerate the pace of human space exploration and research. A space elevator would open up new opportunities for scientific experiments and research in space. One of the most significant benefits of a space elevator would be the ability to conduct long-term research in microgravity. This could lead to breakthroughs in fields such as materials science, medicine, and biotechnology. Scientists could conduct experiments on the effects of microgravity on plants, animals, and humans, and develop new treatments for diseases. As I mentioned earlier, a space elevator could transport large telescopes and other astronomical equipment into space, allowing scientists to observe and study the universe in unprecedented detail. This could lead to new discoveries about the origins of the universe, the nature of dark matter and dark energy, and the behavior of black holes. Answering any of these questions would further our understanding of physics and allow us to push the technological limits. A space elevator could transport advanced Earth observation satellites into orbit, allowing scientists to monitor and study climate change and other environmental phenomena in real time. This could help us understand the impacts of climate change and develop strategies to mitigate them. A space elevator could make it easier to transport raw materials into space, allowing for the development of space manufacturing facilities. Manufacturing in space allows us to take advantage of the unique properties of the space environment, such as microgravity and vacuum conditions. These conditions can enable the production of materials and products with unique properties, such as ultra-pure semiconductors and high-strength alloys. Manufacturing in space could also create new markets and business opportunities, particularly in the emerging field of space tourism and space colonization. It could also enable the production of products that are uniquely suited to the space environment, such as specialized medical implants or high-performance electronics. A space elevator could make it possible to transport large numbers of people into space, opening up new opportunities for human spaceflight. Researchers could conduct experiments on the effects of long-duration spaceflight on the human body and develop new technologies to support colonization of other planets. Overall, a space elevator would significantly accelerate the pace of scientific research and discovery in space, and lead to breakthroughs in a wide range of fields. All this being said, there are some major problems with getting a functional space elevator working. The primary problem being that we do not have a material that would be able to support it. Without something that is lightweight while having an extreme tensile strength, the elevator structure would never make it all the way to space without collapsing. The best option at the moment is thought to be carbon nanotubes. Carbon nanotubes are currently considered to be the most promising material for building a space elevator. However, there are still several challenges that need to be addressed before they can be used in practical applications. While carbon nanotubes have been produced in a lab, scaling up production to the levels needed for a space elevator is a significant challenge. Current production methods are still expensive and time-consuming, and it is not yet clear whether they can be scaled up to the required levels. Carbon nanotubes are extremely strong and durable, but they are still vulnerable to defects and damage. Even a single defect in a carbon nanotube could significantly weaken its strength, making it unsuitable for use in a space elevator. Carbon nanotubes can degrade over time when exposed to heat, radiation, and other environmental factors. It is not yet clear whether carbon nanotubes can remain stable for the decades or centuries required for a space elevator to remain operational. Carbon nanotubes are also currently very expensive to produce, and it is not yet clear whether they can be produced at a cost that is competitive with other materials. Overall, carbon nanotubes offer a promising material for building a space elevator, but we haven't been able to come up with ways to mass produce it to even start testing it on anywhere near the scale that we would need to be sure that they could be used. In addition to the issue of getting the correct material for the job, we need to be able to handle the forces of gravity and centrifugal force on the elevator itself. Earth is constantly rotating on an axis, while gravity is pulling towards the Earth's core. We would need to find the best way to overcome these challenges before we could get further than the idea stage of a space elevator. Gravity poses a significant challenge because the elevator cable must support its own weight and the weight of any cargo or passengers it is carrying. As the cable extends higher into space, the force of gravity decreases, but it never completely disappears. To address this challenge, the cable must be made with a material with a high strength-to-weight ratio, such as carbon nanotubes, and it must be designed to minimize its weight while maintaining its strength. Centrifugal force is another challenge that must be addressed, particularly at the counterweight end of the cable. The counterweight must be massive enough to provide tension to keep the cable taut, but not so massive that it creates excessive centrifugal force at the top of the elevator. To address this challenge, the counterweight must be carefully designed and positioned to maintain the optimal balance between the gravitational and centrifugal forces. To solve these problems, researchers are currently exploring a variety of design approaches and materials for the space elevator cables. Some proposed solutions include using a hybrid cable that combines carbon nanotubes with other materials, such as Kevlar or high-strength polymers, to create a stronger and more durable cable. Another approach is to use a multiple cable system, with several thinner cables operating in parallel to reduce the stress of each individual cable. Nothing has been proven, and we are a ways away of making anything like this become a reality, no matter how cool it would be. For now, space elevators only live in science fiction, and the potential benefits can only be dreamed about. How long do you think it would take for us to get a space elevator? Do you think it would ever be possible? What would be the first space industry that you would want us to focus on once a space elevator is up and running? Thank you all for learning with me. Please let me know if I missed anything or got anything incorrect. I would love to learn more. As always, I appreciate the time that you have taken to watch this video. No matter who you are, you only get 24 hours in a day. Thank you for spending a portion of it with me. See you next time.